All right, so we've focused on using the laws of powers, but mostly one at a time. Many problems will require you to use multiple laws all in the same problem. So let's try some of those. Let's start by looking at this first example. We talk about multiplying powers with the same base. We know when parentheses are bumped up against each other, that's a multiplication problem. And we see that we have the base of a, so that's good. But we also have these coefficients. We consider the coefficients sort of like same bases. They can multiply together. This is a 2 and this is a 7, I realize that, but we know that we can multiply 2 times 7. We've been able to do that forever, right? So 2 times 7 is 14. And then we have a to the third times a to the fourth. We know multiplying powers with the same base, we add the exponents. Remember that little trick that if there's space, you put the plus sign. If they're bumped up against each other, you would multiply. So multiplying powers with the same base, we add the exponents. So that gives us a to the 7th. Okay, so we multiplied the coefficients together to get 14. We multiplied the powers with the same base to get a to the 7th. Let's look at some that use even more rules all in the same problem. Starting with this first one. We have to follow the order of operations, so we know exponents is going to be high on the list, right? Anything inside the parentheses that we could combine, we would, but we don't have any like terms or any powers with the same bases or anything like that. So the first thing we're going to do is we're going to distribute this 3 to every power, keeping in mind that the 2 is raised to the first power and the n is raised to the first power. Any coefficient or variable that doesn't appear to have an exponent does have an exponent of 1. So I'm going to distribute that. That's going to give me 2 to the third, m to the 3 times 2, that's multiplication, a power to a power, 6th, n to the third. We're going to have all of that times 4m squared n cubed. We know we can only multiply powers that have the same base. So I'm going to start off by multiplying the coefficients together. 2 times 4 is 8. Then I have m's. I have an m to the 6th and an m squared. Multiplying powers with the same base, I add their exponents. 6 plus 2 is 8. And then I have n's. An n to the third times an n to the third is going to give me an n to the 6th when I add the exponents. So 8m to the 8th, n to the 6th would be the solution to this problem. There is nothing further we can do. That is completely simplified. Let's look at number 3. On number 3, I have this exponent outside of the parentheses, and it is going to need to be distributed to every single exponent inside the parentheses, again keeping in mind that everything has an exponent. I'm always going to write those ones in so that I don't miss anything when I'm distributing. Now my 2 is going to get multiplied by every single exponent inside the parentheses. So that's going to give me 2 squared. 3 times 2 is 6, so a to the 6th. 1 times 2 is 2, b squared, over 6. 2 times 1 is 2, so 6 squared. 1 times 2 is 2, a squared. 2 times 2 is 4, b to the 4th. So we've used the rule where we distribute the power. We've also used power to power because we know when we raise a power to a power, we multiply them together. Now, we know that we can simplify numbers that are bases when they have an exponent. So 2 squared is going to give me 4, and 6 squared is 36. 2 times 2 is 4, 6 times 6 is 36. A to the 6th, b squared over a squared, b to the 4th. Now I'm going to start my dividing. I know that I can divide powers with the same base. So let's start by simplifying the coefficients. I have 4 over 36, which simplifies to 1 over 9. Okay. I have a to the 6 divided by a squared. We know that when we divide, we subtract. 6 minus 2 is 4, so that gives me a to the 4th. 2 minus 4 is going to give me a negative exponent. So I end up with b to the negative 2. I know that in my final answer, I can never have negative exponents. So in order to get this negative exponent to go away, I'm going to follow the negative exponent rule, and I'm going to put a 1 over it or move it down to the bottom. When I take this b to the negative 2 and I move it to the bottom, the negative exponent goes away. So I end up with just an a to the 4th on top and a 9b to the positive 2 on the bottom. My final answer is a to the 4th over 9b squared. We used many rules in that problem. Let's look at number 4. Same as in example 3, we're going to be distributing the 2 right away, keeping in mind that there's exponents of 1 anywhere that there appears there isn't an exponent. So I'm going to start by distributing the negative 2. This negative 2 right here is going to get distributed to every single exponent inside the parentheses. When I distribute, I am multiplying because that's a power raised to a power. So I'm going to get 3 to the negative 2 power. I'm going to get x to the positive 4 because negative 2 times negative 2 gives me a positive. Y to the negative 6. 6 to the negative 2. I'm taking the negative 2 and I'm distributing it to each exponent. Negative 2 times 5 is going to give me an x to the negative 10. And negative 3 times negative 2 gives me a positive 6. So that first step, I took my negative 2 exponent and I distributed it, multiplied it by every single exponent inside the parentheses. The next step that I'm going to take is I'm going to get rid of all negative exponents right now. The way I'm going to do that is if they're on the top of the fraction, I'm going to move them to the bottom, and if they're on the bottom, I'm going to move them on the top. I'm only going to do that to things that have a negative exponent. And that's because of that 1 over the base raised to the power and taking away the negative, the rule for negative exponents. So I'm going to move the 3 squared to the bottom. The negative went away because it switched places in the fraction. I'm going to move the 6 squared to the top. The x to the 4th is going to stay at the top because it's positive. I don't need to move it. The x to the 10th is going to move to the top. The y to the negative 6 is going to move to the bottom and become positive. The y to the 6 is going to stay on the bottom. It is positive. It doesn't need to move. Now I have all positive exponents. So now I'm going to start moving on. I know 6 squared can be simplified. That's going to be 36. I know 3 squared is 3 times 3, so 9. Now I have multiplying powers with the same base. X and x are the same base. I'm multiplying these, adding their exponents. 4 plus 10 is 14. Same thing on the bottom. I have the same bases. I'm going to be adding their exponents. 6 plus 6 is going to be 12. So I have x to the 14th, y to the 12th on the, those are simplified. I did that by multiplying powers with the same base. Now I see 36 divided by 9 is 4. That would be like 4 over 1, right? So the 4 would be on the top. 4x to the 14th over y to the 12th would be my final answer. Again, we used multiple of the rules, the laws of powers, in that problem. A couple more. Let's look at number 5. We have an m to the negative 5th over m to the 7th times m to the negative 4th. I'm going to start by moving everything so that, no, actually I'm not. I'm not going to move the negatives yet. I'm going to go ahead and, no, let's move the negatives first. Let's do negatives first just to get rid of those. We may still end up with a negative and have to deal with it later, but for now we'll move the negatives. So that means the m to the 5th is going to have to come down to the bottom and become positive. The m to the 7th is going to stay on the bottom because it was already positive. The m to the negative 4th will move to the top and become positive. So again, if you move a term from the top down to the bottom, the negative sign is going to go away. We would only do that if we had a negative exponent. Okay? Now I see on the bottom I have multiplying powers with the same base, so I'm going to add their exponents. That's going to give me m to the 12th, 5 plus 7. And now I'm going to need to use the dividing powers with the same base. When I divide powers with the same base, I subtract their exponents. So 4 minus 12 gives me m to the negative 8th. I know that I cannot have negative exponents in my answer, so I must put a 1 over it and remove the negative. 1 over m to the 8th is going to be the final answer to this problem. All right, last one. Let's do this big one here, and we're going to get to use lots of rules on this one. Look at these as a challenge for yourself. It's kind of like a puzzle. You got to go through, you got to follow all the rules, you got to make sure that you're going step by step, and in the end, you get an answer. It's pretty rewarding. So let's do it. I'm going to start with this first fraction, and I'm going to get it as simplified as I can before I move on to the second one, okay? So let's see what we have. We do have a negative exponent on the bottom, so let's go ahead and take care of that. I'm going to move that to the top and make it positive. Okay. So now I just have 3y squared on the bottom. And I'm going to work down so we can keep these fractions separate. Okay. So now I have x times x to the 4th. Remembering that this is an x to the 1st, I'm going to multiply powers with the same base, which means I'm going to add my exponents, giving me an x to the 5th. Negative 20, x to the 5th. I also see I have dividing powers with the same base. I have dividing powers with the same base. I'm going to subtract their exponents. 8 minus 2 gives me y to the 6th. This is all over 3. So I've gotten that fraction as simplified as I can get it for now. Now I'm going to do the same thing with the second fraction. So let's kind of use this fraction here. I'm going to start by distributing. Remember that if you have parentheses, we always work with that first, parentheses, then exponent. So I'm going to distribute this. My negative 2 is raised to the first power, and my y is raised to the first power. So that's going to give me negative 5x to the negative 3rd, y to the 5th. I didn't do anything to the top yet. And then negative 2 to the 3rd, y to the 3rd. Okay? Now I'm going to move negative exponents around. Now, I do want to point something out here. This is negative 2 to the 3rd, and this is a little side note, but this is very important. Let's look at it. Negative 2 to the 3rd versus negative 2 to the 3rd. Why are these different? Let's type them in our calculator and see. Negative 2 to the 3rd, remember we used that caret, is going to give me negative 8. Negative 2 in parentheses to the 3rd. Oh man, it doesn't work because this is an odd exponent. Okay, bad example. But let me explain what I was going to say. Negative 2 to the third says raise positive 2 to the third power and then make your answer negative. So let's say that this was a negative 2 squared. Let's do it with squared. Negative 2 squared versus negative 2 squared. Negative 2 squared is negative 4. But open parentheses, negative 2 close parentheses squared is positive 4. The reason is this first example is telling the calculator take 2 and square it, so that's 2 times 2, and then make the answer, do that first because that's an exponent, and then PEMDAS, we have to do exponents first, then make the answer negative. This one is telling the calculator negative 2 times negative 2. A negative times a negative gives you a positive. So always be real careful if you're typing things into the calculator that you type them in the way that they're told to you. So this one is going to do 2 to the third and then make my answer negative. So this is going to be negative 8. Okay? So I'm going to rewrite it. I'm going to simplify that to negative 8. So I have negative 5 on top, negative 8 on bottom. I'm going to move the x to the third down because it's negative. The y to the fifth is going to stay on top. The y to the third is going to stay on bottom. So I simplified the negative 2 to the third, and I made the x to the negative third go downstairs so it could become positive. Now I see that I have dividing powers with the same bases. Negative divided by negative is positive, so I'm going to turn this whole fraction positive. So I have 5 y to the fifth divided by y to the third. I'm going to subtract 5 minus 3 is 2, y squared over 8x cubed. Okay, negative 20 x to the fifth y to the sixth over 3 times 5y squared over 8x cubed. Just going to go through and multiply what I can, okay? So I have negative 20 times 5. Remember the coefficients. We can multiply together, so that gives me negative 100. I have this x to the fifth that I'm going to go ahead and move over. And then I have y to the sixth times y squared. This is multiplying powers with the same base, so I'm going to add the exponent. 6 plus 2 is 8. On the bottom, I'm going to do the same thing. 3 times 8 is 4. So let me multiply 3 times 8 to get 24. And x to the third did not have anything to combine with. So all I did, when you multiply fractions, you multiply top times top, bottom times bottom. So I did that step. My final step is going to be simplify anything in here that I can. Negative 100 divided by 24 is going to reduce to negative 25 over 6. Okay. Remember, you can type that straight into your calculator. When you get a decimal, you hit math, enter, enter. That will change it into a fraction for you. I have dividing powers with the same base, which is 5 minus 3 is going to be 2. And then this y to the 8th doesn't have anything to combine with. So there is our final answer. This big old problem turned into negative 25x squared y to the 8 over 6.